Hello, everyone. Welcome to the second lecture on Introductory Statistics. In the first lecture, we talked about what statistics is and introduced some very basic concepts about statistics. And in a typical statistical study, we have a population that is a complete collection of all objects of interest in the current study, right? That's a population. And then we select a sample from the population. Now, what is the sample? The sample is a subset of the population. We get a sample through a sampling method. And then we collect the data from the sample. And after we got the data, we use descriptive statistics to study the properties of the sample data. And then in inferential statistics, we make inference about population based on the sample data. Okay, basically, this is the whole picture of what we do in statistics. All right, so very good. All right, now, and then a very important step in any statistical study is the sampling method. All right, so we want to select a sample from the population. How can we select a sample from the population? That is using some sampling methods. And we talked about why we do sampling, and also it is very essential to get a representative sample of the population, right? And then we introduced the definition of a sampling bias. Right? What do we mean by a sampling bias? Right? So what is a biased sampling method or unbiased sampling method? And then in last class, we talked about convenience sampling and also what? A voluntary response sampling. Okay, so like these ones, right? So we give this definition here, the voluntary response sampling. What do we mean by this, right? So it is mainly emphasize on what? It is the respondents who decides to be included in the sample. Okay, so like the internet pools, all right, so you have no control on who will give you a response, right? So the respondents decide to be included in the sample, like telephone polls, mail-in polls, and so on. So these are the voluntary response, all right? The voluntary response is not enforced, right? People who chose to get included in this type of samples. Now, let's consider this example. All right, so it states the following. A newspaper posted this question on its website. How often do you seek medical information online? All right, so of this 1,072 internet users who chose to respond, 38 of them responded with frequently. Okay, so what term is used to describe this type of survey in which the people surveyed consists of those who decided to respond? Okay, so this is what voluntary response, right? Because what the internet who chose to respond. So these respondents made the decision, right? So they are from a voluntary base. So this is so-called voluntary sample. It is a voluntary sample. Now, what's wrong with this type of sampling method? Okay, what's wrong with it? All right, so this is usually what? Usually not a representative of the general population, and it's biased, right? And have no control on the researcher, have no control on the formation of the sample. So this is our answer. It is a voluntary response sample, and many people may choose not to respond to the survey. Responses may not reflect, all right, may not reflect the opinions of the general population because it is not representative of the population, right? So it's not representative. Very good. Now, in some other cases, we also have so-called source bias. all right? Source bias. Now, in those conditions, a given source has the potential to create a bias in a statistical study, all right? So in other words, we say the survey has a source bias. Consider the following examples. Say the first one, National Shooting Sports Foundation conducted a survey showing that a question about the gun policy. Their survey results showed a higher percentage. 53% said it was more important to protect the rights of Americans to own guns than to control gun ownership. Now, this example contains a what? A source bias. There is a source bias here. Now, why? Why there is a source bias? Now, because what? Because this survey was conducted by the National Shooting Sports Foundation. Okay, so by its interest, it has the potential to create a bias in a study. So it contains, there is a source bias involved in this survey, right? So usually, that's why usually we want to, people tend to believe in the study, the results from some independent agency, right? Instead of the agencies who have interest in these policies. Okay, so here, apparently, we do have a source bias. Sorry. Okay, second, before vote, a government-sponsored agency conducted a survey on unemployment rate. Of course, right? So before vote, a government-sponsored definitely is not an independent agency, right? Apparently there is a given a potential to create a bias in their study. So therefore, there is a source bias as well. Okay, so there is a source bias. Okay, all right, let's go to the next. All right, so now we have introduced some biased sampling methods like a convenience sampling method and a voluntary response method, and also maybe a source have a bias, or a source bias, right? Now, let's consider a very common unbiased sampling method called simple random sampling. All right, it is important to select a representative sample from the population. Now, let's consider this sample. Definition: a simple random sample of size n is a sample selected from the population in such a way that each sample of size n has the same chance of being chosen as any other sample of the same size. Okay, as a sample of size n, any sample of size n has exactly the same chance to be selected. Okay, in this case, we call it is a simple random sample. All right, it is often called a random sample. We can get a simple random sample using a method called a lottery method. All right, so how can we get a random sample using the lottery method? Okay, here are 3 steps. Okay, step 1, assign a number from 1 through n to each subject in the population of size capital N. All right, that's the population. All right, then second, randomly selected sample of n numbers, lowercase n. This is the sample size from the list 1 through capital N. And then the subjects with the numbers in the selected sample are gathered and they form a simple random sample of the whole population. Okay, so here there is a randomly select a sample of n. All right, how to do that? Usually these days we can easily get a sample of n numbers using what? Using some computer softwares or statistical software like R, MATLAB, SAS, and so on, right? Python, and these are all can be easily done. Okay, So this is a lottery method. Let's consider example here and show how we can select a random sample using the lottery method. Now, assume there are 250 employees in a company, and we are to select a simple random sample of size 25. All right. So how do we do this selection? Okay, we follow those 3 steps. All right. So in the sample, in the population, there are 250 employees. So each employee can be assigned a number from what? 1 through 250. Okay. So we got each employee got a number from, all right, 1 through 250. And then we can obtain a random sample of 25 numbers because, okay, here is n is 25, right? So we want to select a simple random sample of size 25. So that's why we are going to select 25 numbers from 1 to 250. Now we can use many softwares to do so. Okay, and then what? The employees with the numbers in the random sample are selected, and they form a simple random sample of the population. Okay, so this is usually the lottery method. Okay, so it is used to select a simple random sample, and simple random sample is usually representative of the population. All right, it's an unbiased one. Now there are also other sampling methods. All right, so let's consider some of them here, which are commonly used in practice. The first one is called a systematic sample. So what is a systematic sample? It is a sample consisting of every case subject. All right, here it's better to say every case subject from a population listed in a sequence. All right, it's listed in a sequence. 1, 2, 3, 4. It's listed in order. And we are doing what? Every case subject. For instance, every second, every other one, right? Every third, every fourth, and so on. Every 10th subject, all right, in a sequence. So this is a systematic sample, all right, systematic sample. Okay. Then a second one is called the stratified sample. So what do you mean by stratified sample? All right, it's a sample obtained by subdividing the population into strata, all right, with the same properties. Okay, so there is a process of dividing the population into stratas with similar or same properties. Okay, now for instance, you can separate the class into a group of female students and the other group of female students. There is a dividing process involved here, right? So in each of the subgroup, they have some common property, like female students and male students. And then what? After that, we draw a simple random sample from each strata. Okay, so that is the stratified sample. Now, so stratified sample you can make sure that you have someone, all right, at least some observations from each strata, okay, compared with a simple random sample. Now, for instance, if you select a sample of 5 students from the class, right, from a class. So these 5 students may be what? If you take a simple random sample, it can be what? All of them can be female students, right? It can be all male students, right? So that's a still simple random sample, right? So you can you may end up with all 5 of them being female, all 5 of them being male. Now, if you want to say to include both female and male students, you can do stratified sample, right? So in this way, you firstly divide the class into 2 groups, female group, male group. And then what? In the female group, you randomly select, say, three female students, right? Randomly, simple random sample from the female group, and 2 from the male group. And then add them up, you got what? 5 students. Now, you can guarantee that you have 3 female students and 2 male students in this way. That's the advantage of stratified sample over simple random sample. If you want to guarantee that you have representatives from each strata, okay, then stratified sample. And then last one we want to talk about, introduce, is the cluster sample. Right? It is a sample obtained by dividing the population into clusters. Okay, into clusters, and then what? Randomly selecting some of these clusters. All right, here we perform this simple random sample to the clusters, and then what? And then choosing all the members from those selected clusters. Okay, selected clusters. Okay, now consider an example in, say, in Kentucky, right? So there are many counties, or we can simply randomly select 2 counties from Kentucky and survey all the household in Kentucky, right? So that is going to be a cluster sample. Okay, so these are the 3 very commonly used sampling method in practice. Okay, systematic, every case subject from a population in sequence. Stratified, all right, you divide into strata of similar properties, all right, especially strata with similar properties. And then you draw a simple random sample from each other. For cluster, all right, for cluster sample, you divide the population into clusters and what? Randomly select some of the clusters, but you choose all members from those selected clusters. All right. So this is these 3 commonly sampling method. Now let's consider an example here. Determine the type of samples for the following. The first one, a researcher conducted a survey on learning habit of students from his university by identifying groups of male students and female students, and then what? Randomly selecting 15 students from each of these 2 groups. So this is what? All right, as we said, this is what? You have female students and male students, and then randomly simple random sample from each of these groups. So by definition, this is what? A stratified sample. All right, this is stratified. All right, it's a stratified sample. Second, a student conducted a survey on family sizes of households in Kentucky by randomly selecting 3 counties and surveying all the households in those selected counties, right? So here, random size is about the counties. Here, counties is going to be like the clusters, right? And then we are going to survey all the households in those selected clusters, which are the counties in this example. So therefore, this is what? Okay, by definition, this is a cluster sample. All right, finally, quality engineer selects every 10th product from the production line from 8 to 5 p.m. in a day, and then test the quality of these selected products. Now you can see, right? So it's taking every 10th product. Now from a production line, so as you can see, there is an order, right? There is a natural order from the morning to the afternoon. So therefore, this is what? A systematic, because it's every 10th, right? Systematic sample. Very good. All right. So these are the common sampling methods which are in practice. All right. But in some cases, right, the sampling procedure can be very complicated. It may consist of several stages. All right, and in each stage, they may use what? Different methods. Consider this example. If we want to conduct a survey about the household income level in the United States. All right, so let's consider it incorporates the multi-stage sample design as follows. All right, one, we divide the United States is divided into what? 500 regions, okay, which then grouped into 50 different strata. All right, 50 different strata. This is going to be the first to divide the United States into 500 regions, and which are then grouped into 50 different strata. So on average, there will be 10 regions in each strata, right? On average, there will be 10 regions in each strata. And then second, in each of the 50 strata, we randomly select 2 regions. All right, here you go. Right, in each of these 50 strata, we randomly select 2 regions with the probability of being selected, okay, proportional to the number of households in each region. All right, so here you see we got a random sample, right? Randomly select in each of the 50 strata. To get what? To get regions. How many regions do we get? All right, so we have what? 50 strata, and each strata we select 2. So 50 times 2, that's 100 regions. So you see that after the first 2 steps, we got a sample of 100 regions. Now, this is going to be our first stage. All right. So the first stage is to get a sample of what? 100 regions. Okay. Now, how to do that? All right. As you can see, we group these regions into what? 50 different strata, and in each strata, we randomly select 2. Right. So therefore, how many? What is the method here? All right. What is the method here? It's a stratified sample, right? So this 100 regions is a stratified sample. We use the stratified sampling method. Okay. So a sample of this one, we used the stratified sampling method. Okay, so this is in the first stage. We use the stratified sampling method. Now, how about that we are trying to find is what? The household income level, right? So then we got to move on with our sampling, right? Then what do we do? After we got 100 regions, this part, in each of the 100 selected regions from the previous step, 3 counties are randomly selected, and all the households in those selected counties are surveyed. So this is going to be our second stage, is to select how many counties are selected in this way. So 100 selected regions, in each region 3 counties. So in total we have 100 times 3, no, 100 times 3 counties, right? 100 times 3 counties are 300 counties. Now, and for these 300 counties, we select all the households in this survey. All right. So now here is to get a sample of households in each region, each selected region. What do we do? In each of the region, we randomly select 3, right? And then take all of them, all the household in those counties. So this is what cluster sampling method. All right, so you can see that we are using different sampling method at a different stage, right? So this is the multi-stage sampling. Now, of course, there are here in this example, we have 2 stages. Now, in some other examples, we may have more stages, and those are going to be more complicated. Okay, all right, but this is a introduction on this one. All right, so next we're going to move on to section 3. All right, it's about data types. Okay, now we say that we want to collect a sample from the population, and then what? Then we want to collect the data from the sample, right? So then key question is, what are data? Right? What are data? What do we mean by data, right? So now it is essential that we can study the data nature of data. Okay, so now types of data. Now let's see some classification of data. Okay, so here I give 2 definitions of the 2 classification of data by nature. Now, one is quantitative data. All right, so what are quantitative data? So quantitative data are data that can be counted or expressed numerically. All right, such as class sizes is a count, length, volume, speed. They're all called numerical data. Okay, it is in many cases it is a numerical measurement or counts. Okay, numerical measurements or counts. Okay, that's quantitative data. They are also called numerical data. Okay. Now, second class of data are these qualitative data. Okay, qualitative data. So what are qualitative data? Now, qualitative data are the data that describes the qualities or characteristics such as a color, material, language, region, etc. Okay, so they are also called categorical data. All right, so they are quantitative data or qualitative data. Okay, so these are the definition. Now let's consider some examples. Oh, no, not examples, but this one is going to be the levels of measurements. All right, let's consider some levels of measurements. Okay, the data can also be categorized based on what different levels of measurements. Okay, at the first level, we want to introduce is so-called the nominal level. All right, what are nominal level of measurements? Well, data that it means the data that cannot be arranged in a natural order. All right, be careful here, in a natural order. Now, examples includes what? The gender, right? Female or male. You cannot put it in a natural order, right? A race, color, right? And say your occupation, right? So you may be and so on, right? And apple, fruit, right? Fruit is apple or orange, right? So or a pear, right? So and so on. So these are nominal. These are at a nominal level because what? They cannot be arranged in a natural order. In a not natural order, there's no natural order among them. Okay. So second level is called the ordinal level. So ordinal level, what do we mean by ordinal level? So those are the data that can be arranged in order, but all right, their difference either cannot be found or are meaningless. Now here, the difference, it is the mathematical difference, all right, subtraction, right? Whether you can take the subtraction or not. Subtraction, all right? It's not the, are they different or not, right? It is the difference, which means subtraction, mathematical subtraction, okay? So if their difference either cannot be found or are meaningless. Examples include what? The occupation ranks, like full professor, associate professor, or an assistant professor, right? So the occupation ranks. These ranks are what? At ordinal level. There is they can be arranged in order, right? So like this, a full professor, associate professor, and assistant professor. So there is a order there. They can be arranged in order. And also what? Can we take their difference, the subtraction? What is the difference? What is the difference between the full professor minus associate professor? Well, I know there is a difference between them, right? The full professor and the associate professor, there is a difference, but there is no mathematical difference. We're saying the mathematical subtraction. You cannot take what subtract associate professor from full professor, right? That doesn't make sense. Okay, so that is to say it occupation rank, all right, ranks is at the ordinal level. They have an order, but they cannot take the difference, cannot take the subtraction. And also say degree ranks, degree types, right? Bachelor's degree, master's degree, and doctor's degree, right? So these are all ordinal level data. Next level is going to be the so-called interval level. All right, the interval level. What do we mean by interval level? So data that have an order. All right, it can be ordered, right? It has an order along a scale, and have meaningful differences. You can take the subtraction, right? You can take the subtraction, meaningful difference. Again, this difference is the mathematical difference. All right, they have meaningful differences, but what? There is no natural, it's better to say zero starting point, right? No natural zero starting point. Okay, no natural zero starting point, and ratio does not make sense. Okay, what do we mean by that? All right, so consider these examples, like temperature. So think about temperature, right? Of course, there is an order, right, along a scale, right? Different degrees, all right? 32, all right? 50, 60, and then 100, and so on, right? So it is, there is an order along a scale, and we do have meaningful differences. You can do the subtraction, right? So you have in the winter time, right? So you have in the building, you have a temperature, the indoor temperature, and you also have outdoor temperature. There is a difference between the indoor and outdoor temperatures. So they do have the meaningful differences, right? You can do the subtraction. But what? There is no natural zero starting point, right? No natural zero starting point. What do we mean by that? Oh, 0 degree? Well, that's not the natural zero starting point. A 0 degree is still a degree of the temperature. It's a measurement of the temperature, right? So 0, you also have negative degree, right? -1 degree, -2, and so on. So there is no natural zero starting point, and the ratio does not make sense. Now, for instance, 32, we know that 32 degree is at 32, the water will turn to ice, right? Turn to ice. Now, how about 32 times 2? What do we mean by 64, right? 64. So what do we mean by 64 is twice 64 degree as the temperature is twice as what? As 32. So as what? As hot as or as cold as, right? No, it doesn't make sense. You cannot take the ratio, right? So because what? The temperature at 64, we are feeling very comfortable outside, right? 64 is pretty good, but 32 is freezing. All right. So there is no like the ratio. All right. You cannot say like 64 degrees is twice as hot as 32 or as cold as 32 degree. The ratio does not make sense. Okay. So this is the temperature. And also, of course, year of birth, right? Year of birth is also at the interval level. For instance, year 2000. If you're born at year 2000, right? Now, year 1000, and year 0, right? And you have years BC and years AD. Now, these years have an order along a scale. And then you can take meaningful differences, right? 2000 minus 1995, that's 5 years in between. It makes sense to take the difference. However, do we have a natural zero starting point? Natural zero starting point. We do have year 0, but that's not a natural zero starting point, right? There are still time years ahead of that. Year 0 is just a man-made point along the time scale, right? Along the scale. So that's year of birth. Okay. And then what? Finally, all right. The fourth level is the ratio level, right? And what is the ratio level? Okay, those are the data for which there is a natural zero starting point, and the ratios do make sense, right? So there is a natural, for instance, the height, right? Height, there is a natural zero starting point, right? 0, no height. Or weight, right? So you can also take a ratio, right? This watermelon is as twice as heavy as that one, right? So you can take the ratio. Okay, distance, speed, and speed, right? Speed, a natural zero starting point. You parked the car in the parking lot, so the speed is 0, right? The speed is 0. Now, the speed can also make ratios, right? You can take a ratio, right? So, like if you drive in the highway, your speed may be 70 or something like that, right? 70 miles per hour. But if you drive in local, it may be 35 miles per hour. Right? That's twice as fast as 35. It makes sense to take the ratio. Okay, that's the ratio level. All right, these are the 4 levels of measurement. You have nominal level, ordinal level, interval level, and what? Ratio level. Okay, these are 4 levels of measurement. Okay, so we need to know how to determine the given data. We need to determine whether they are quantitative or qualitative, right? And then what? We need to also know at what level of measurements are they? They are. Okay, so let's consider several examples here. Now consider this example. For the following data, determine if the following data is quantitative or well, categorical is the same as what? Qualitative, right? Okay, sorry. Qualitative. It's the same as, all right? It's quantitative or qualitative. I say that, all right? Then also determine what level the data are at. Okay, the level of measurement. Now, persons A, the persons of state of residence. How about this one? This is what? Okay, the state of residence in the United States you have what? Different states, right? So these are at what level? Okay, and so at what level? Can we order these states in a natural order? No, right? So you have different states. You have California, New York, North Carolina, Kentucky, Tennessee, right? So there is no natural order among them. Okay, so what is the level? All right, what is this level? So that's what? Nominal level. Okay, so firstly, this is, before that, right? So what is a quantitative or qualitative? It's a quantitative or qualitative. So this is what? A residence of state. It is qualitative, right? Because it's to describe the quality or characteristics such as the region and so on, right? So therefore, this is qualitative. Qualitative, and it is at the nominal level. Okay, it's nominal level. All right, that's the first one. Now, a person's year of birth. All right, year of birth. Well, I think we just did this one here. We just list this one as an example, right? Now, this one, year of birth, is this what? Firstly, numerical value or a quantitative value or categorical value? Okay, so this is what? This is a quantitative value, right? Because what? It's like a count, the number of years after year 0 and so on, right? So that is a quantitative data. Quantitative, and the level is at the interval level. Interval level. All right. Now, the third one, a student's number of absences from classes in a semester. Number of absences. So it is a count. So since it's a count, so it's a quantitative data, right? So it is a quantitative data. It's a quantitative data. And for this one, what is the level? The number of absences. Nominal? No, right? There's an order there. Well, it's a long scale, right? So ordinal, oh no, right? So it should, the difference makes sense, right? The difference, you can take the difference between number of absences. How about the interval level? Is that interval level or not? There is an order along scale and also have meaningful differences. Oh, but we do have a natural 0 starting point, right? So if you have never missed a class, in that case, you do have a natural 0 starting point, right? And the ratio makes sense, right? For the number of absences, right? So, if you miss 4 classes, I miss 2, then yours is twice as much as mine. So the ratio makes sense. So therefore, it is not nominal, not ordinal, not interval, but what? It is a ratio level. All right, it is at the ratio level. There is a natural 0 starting point, and the ratios make sense. Okay, so this one is at ratio level. Okay, now finally, let's consider this one. Students' letter grade in our class. Letter grade. That's not numerical grade. All right, so letter grade. So there are A, B, C, D, F, right? So these are the letter grade. Now, because it is letter grade, it's not a numerical, it's not a count, right? So it is to describe the qualities, right? So therefore, it's a qualitative data. Okay. Now this one is qualitative data. And what level are they, is this at? A, B, C, D, F, the letter grade. Okay, so it's what? It's there is order, right? A, B, C, D, F. And data can be arranged in order, but it's ordinal level, right? It should be ordinal level. Do they have a meaningful difference? A subtraction? I mean, the mathematical subtraction, all right? Whether A minus B makes sense or not. No, doesn't make sense. So it is what? Ordinal level. There is order, and the difference does not make sense. So therefore, this is ordinal level. Okay, all right. Very good. All right. So given data, we need to know what type of data they are, or whether it's a quantitative or qualitative. And then also we need to be able to determine the level the data is at. Okay, so that's very important. Okay, all right, this is the end of the chapter 1. All right, so in chapter 1 we give a brief introduction to statistics and introduce several important concepts. And the statistical study, right? The population sample. You have descriptive statistics and also inferential statistics. And in section 2, we talked about the sampling method. And then in section 3, we talked about data types. Now, let's move on to chapter 2. Okay, so now let's move on to chapter 2. Okay, in chapter 2, we are going to give a presentation of data. All right, now is the data presentation. How can we present data? Section 1 is a frequency distribution table. Now consider this one when we, right, especially when we work with large data sets, right? A frequency distribution is often useful in organizing and summarizing data. Okay, it helps us to understand the nature of the distribution of a data set. All right, so let's consider this example. Suppose that we are interested in the weights of male students in our statistics class. Now say that there are 25 men in the class, and then we measure each man's weight with the results shown below. All right, so here is all the weight we get for this 25 men in the class. Okay, so let me just ask you a question. All right, how many of these men are over 190? How many of them are over 190, or including 190, greater or equal to 190? How many of them are there? You got to be careful, right? So I believe there are what, 190? Here is one, and what, 197, right? So I got two. There are two of them, right? Now, okay, you can by checking every single point, you found that there are two students who are over 190. Okay. Now, how about, let me ask you another one. How many of them are below say 170, less or equal than 170? You got to what? You got to be careful. You got to check less or equal than 70 for every single points, and count it and find out this reason. Find out this number, right? So of course, is that easy? That's not. You got to count, for every value, and see how many are there which are below 170. Right? Okay. Now, how about I give you the following table? All right. Consider this table, right? Now, let me ask you the same question. How many of them are at least 190? Now you can see that clearly there are two, right? So there are two. Now, another question, how many of them are below or less or equal than 170? Less than, strictly less than, let's say strictly less than 170. All right, strict here. Let's say strictly less than 170. Okay, how many are there is strictly less than 170? And you can see, right? So add these up, right? You can get the number of individuals who are less than 170. So that's what? 16, right? That's 16 of them. So you can easily calculate, get an idea about the distribution of the data easily using this table, right? Instead of what? Considering this raw data, right? You got to count for every single question here. Now, here you simply do the summation and you can get it. So, as you can see, this table helps, all right? Helps us understand the nature of the distribution of the data set. Okay, so this table, all right, this table is usually called what? A frequency distribution table. Now consider the definition. What is a frequency distribution table? Now, a frequency distribution table shows how data are partitioned among several categories or classes by listing the categories. All right, you have one column of categories or classes or intervals, right? Along with the number of frequencies, along with the number, all right, or the frequency of the data values in each of them. Okay, like what do we have here? You have a column here of the class intervals, that's the categories, and also you have what? Another column here as the frequencies in each of the corresponding interval or categories. Okay, so this is going to be a frequency distribution table. Now, for a frequency distribution table, we have some really important terms. Okay, what are they? All right, we have the lower class limits, upper class limits, interval width, and finally frequency. Let's firstly consider lower class limits. What are lower class limits? The lower class limits are the smallest numbers that can belong to each of the different classes. Okay, different classes or different categories or different intervals involved in a frequency distribution table. Now, for instance, consider this example. What are the possible classes or categories? Now, here you can see that these are 1, 2, 3, 4, 5, 6, 7, right? There are 7 class intervals. So 7 categories. Okay, now what are the lower class limits? That's the smallest numbers that can belong to each of the different classes. Now, for instance, what is the smallest number can be in this interval, in this class? That's from 190 to 199. So the least possible value is 190, right? So therefore, this is the lower class limit for this interval, for this class. Okay, now for this class, for the second class here, now the smallest value is what? It's 180, right? So that's the lower class limit for the second one. And similarly, this is 170, 160, 150, and 140, and 130. Right? So these are the lower class limits. Does that make sense? Okay, so by definition, that's the smallest numbers that can belong to each of the different classes. So we have all these smallest numbers in each of the class intervals. Okay, so those are these lower class limits. And similarly, we will have the upper class limits. That's the largest number can belong to each of the different classes. Similarly, we will have what? 199, 189, 179, 169, 150, 149, 139, right? So these will be what? The upper class limits. Okay, all right. And then next is the interval width. All right, interval width is the difference between two consecutive lower class limits, or two, okay, here is again consecutive. All right, two consecutive lower class limits. All right, so that's the interval width. Now for us, all right, you consider any two, all right, consecutive lower class limits. So these are the lower class limits. Now, for instance, these two are 190 minus 180 equals what? 10. So 10 is the interval width, or because what? It is the difference between two consecutive lower class limits. So 180 and 190, they are consecutive lower class limits, so their difference is the interval width. Now you cannot say that 190 minus 160. This is not, even though 190 and 160, they are both lower class limits, but they are not consecutive ones, right? They are not consecutive ones. So this is not true. You can also find this interval width by using what? Another pair. For instance, these two pair, right? So 150 minus 140 equals 10. So as you can see, as long as you got two consecutive lower class limits and take the difference, you got the interval width. All right, so this is the interval width. Be careful. All right, there is a typical error involving about the when you want to calculate the interval width. All right, many of the students tends to use what? The interval width is what? The upper minus lower. So for instance, 149 minus 140 equals 9. Now, this is not correct. This is not correct. All right. So by definition, you got to select what? Two consecutive lower class limits or two consecutive upper class limits, like the say here 199 minus 189, and that's also 10, and so on. So you got to be careful on that. All right. So, and then frequency. What is the frequency, right? So frequency is the number of iterations that occur in each interval a variable occurs. All right. So now for this one, let's say that here. All right. Let me just clear some of this. Okay. For instance, I have here, say this one is a 3. 3 is one of the frequency. Is corresponding to this interval 170 to 179. How do we got 3 here? All right, so we're going from this table between 170 to 179. So you can see that how many are there? 170. Okay, so there's one between 170 to 179, right? So here's another one, and here's another one, and no others. There are 3 of them, right? So 3 of them. 3 values are between 170 to 179, and that is why we have 3 here, right? So another example here is 2. So there are 2 of them in between 190 to 199, as we just showed. This is 190 and this is 197, right? So, all right. So these are the related terms about a frequency distribution table. All right. So for this example, as we just showed, right, the lower class limits, 130 through 190, upper class limits, 139 through 199. All right. And the interval width, be careful, it is 10. All right. 2 consecutive lower limits, or 2, here is again consecutive. Or consecutive upper class limits. All right. Be careful. Now, let's consider example. All right, consider the following frequency distribution table weights of a random sample of adults. Now, can you please find out the lower class limits, the upper class limits, and what? The interval width, right? So what are the lower class limits? Now, by definition, the lower class limits are the smallest possible value in each classes. So that's going to be what? All right, 60, 90, 120, 150, 180, and 210, right? So those are the lower class limits. So 60, 90, and 210. Okay, so what about the upper class limits? All right, we have 89, all these ones, right? So those are the upper class limits. This 1, 2, here's 89, 119, till 239. Okay, so these are the what? Upper class limits. Now, third, so what is the interval width? All right, interval width. All right, let me know if I'm right. All right, interval width, for instance, for this is an interval, I'm saying that this is 89 minus 60, which is the width, 29. Am I right? Am I right? Okay, this is not right. All right, by definition, what do we mean by the interval width? The interval width is, by definition, the difference between two consecutive lower class limits, right? For instance, you have what? 60 and 90, right? Or 150, 180. These are the consecutive lower class limits. And take the difference. For instance, you have what? 90 minus 60? That's 30. So 30 is the interval width, right? It's an interval width. Now you can also find this one using this consecutive pair. So 180 minus 150, so which is also 30, right? Now you can also using a pair of upper class limits. So as long as they're consecutive, right? For instance, you choose this pair. So 179 minus 149. Again, you got 30. So 30 is the interval width. Okay. All right. So that's all about this lecture, and we will continue to the next lecture next time. All right. Thank you for your attention. That's all for today.